Coming up on the FTC Open Alliance show. It's our first show with FTC 12736 Electric Mayhem Green, and 12736 is one of the founders of the FTC Open Alliance, so we'll discuss a bit more about its founding. Then we have a lot of great robot progress discussions from strategy, the CAD overviews, prototypes, and a bit more on their experience with the Limelight 3A and how it could be revolutionary for teams. Let's get ready for the FTC Open Alliance show. This video on fun is brought to you by viewers like you and also in partnership with the following. Studica Robotics is everything your team needs to build, learn, and compete. Check out their FTC Starter Kit, Intake Hub Kit, and odometry wheel options at studica.com/robots. Teams in the USA can get up to 25% off and apply for grants at studica.com/robots. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. In our first ever FTC Open Alliance show, we're joined by 12736 Electric Mayhem Green. Guys, welcome on, and why don't you introduce yourselves? Let us know what you do on the team.
Yeah, I'm Oscar, and I work as a mechanical and CAD person. This is Nate, and he does primarily the same. And Hamid works as a programmer and on the more information technology side. And later, Etienne will be joining us. We are, as you said, Electric Mayhem 12736 from Buffalo, New York.
Awesome. Well, welcome in. And I got to ask you, I know you were pivotal to getting the FTC Open Alliance movement going for it. What made you want to do something like this? And give me some more details on kind of the backbone behind all this.
Definitely. So FTC Open Alliance is a project that we started this summer in preparation for this FTC season. And we really just looked at what FRC has been doing with the Open Alliance, and we thought that we could definitely bring that sort of space for collaboration between teams to FTC. And so over the summer, we've built out some infrastructure like a website where teams can basically sign up and they can share their CAD, they can make a build thread on Chief Delphi, and they can share their code and a whole bunch of other things. And really why we wanted to do that is just because we wanted to sort of make a place that teams can go to just share their progress throughout the season for other FTC Open Alliance teams and also just anyone else in general. The information's available to anyone who wants it, and signing up is as easy as we can make it because we want as many teams to be able to share their knowledge and their progress in a season with the rest of the community.
Well, really cool, Matt. One thing I ask you is, so what are some of the other teams that are participating in this? We got your website up here. Talk to us about some of the other teams that have joined up for this. And if other teams want to do anything, how can they join?
Yeah, so we've actually got the teams page pulled up here, and we've actually got 10 teams, including us and our sister team, Electric Mayhem White. Now, it does only look like there's 8, but a couple of them also are sister teams. So we've got some great teams on here. And if other teams that are watching the show want to register, FTCOpenAlliance.org is the main website, but then there is a register link that will take you to a Google form. And much like the Open Alliance does it, we're just going to have you write down your team number, team name, and then a whole bunch of other information like links and sort of general statistics about your team this season.
So teams can go to ftcopenalliance.org to find out what teams are participating. You can click on those links I see. That's really, really cool, Matt. So congrats on a great start so far, and we can't wait to dive more into that. But let's get to your robot for a few things as well, too. Lots of stuff to dive into. What do you want to start out with first?
I think the logical place to start would be a game strategy coming out of kickoff. So on that note, coming at right after kickoff, one of the first things we decided on is we wanted to build a robot that could play in all corners of the field. So it could hang on the chamber, it could climb to the maximum point level, and it could also place in the basket. But the real debate coming out of that was, what do we want to focus? And doing the point calculation and also just thinking about what skills, what our strong suits as a team are, we decided that hanging on the chamber would be our main focus, while having having the ability to score in the basket, but kind of minimizing that to focus on the chamber, and also prioritizing getting that max point climb coming into our first competition, because we think that's going to be critical very early on in the season. So yeah, and then the way we did that is we after we had decided on all that, we went into more robot design sort of things. We wanted to make sure that we could reach as far into the pit as possible, or into the submersible as possible, to grab specimens. And one of the other things we decided early on was we drivetrain, which is a pretty unique drivetrain for FTC, but this year especially, we wanted to pick it because we like the versatility of it. It's a very fast drivetrain. It can spin and move at the same time, which especially for a game this year, which has a more possibility for defense. We thought that was good, so we could get out of situations where we could get pinned. It's also a very light drivetrain, which will make a end game climb significantly easier. And another thing we did on the drivetrain, something I focused on a lot, was when building it out, we tried to make as much of it configurable as possible, so that during the CAD process, when we were iterating on it, say we wanted to change the diameter or how tall it was, very simply, we made a pretty basic Kiwi drivetrain very configurable. So you can change the diameter using Onshape's configurable tools. You can also change your spacer height and also what type of wheels you're using on your drive, on the Kiwi drive, which was something which was a new experiment for us as a team. It has worked out greatly so far.
I do want to ask you, what made you want to, try doing a Kiwi
and then
drive?
moving
'Cause that's
in,
something that's been around for a long time in FRC, but that's been seen for a long time. In FTC, we don't see that very frequently. So, what made you want to have that ambition to go to something like this, and what have you learned so far?
So we've done Kiwi drives as a team the last couple of years. We've been doing pretty consistently since 2022. We like the fact that it's only 3 motors, which gets you another motor slot to use on some subsystems. We also like the how light it is and the versatility and speed of it.
That's really cool. I just love seeing that. What else do you guys want to go through?
So I think up next, intake is probably what makes the most sense. Originally coming out of doing our 30 hours challenge, which we participated in, we the first prototype intake we had were 2 counter-rotating wheels to grab the block on the side, kind of like a reverse baseball pitching machine. But then we looked at some teams on the Open Alliance, the FTC Open Alliance, and we saw that they were having a lot of success with over the sample intakes. So we pivoted to something more like that. And this is a current working design with these green cut compliant wheels from Andy Mack to grab over the get over the sample, and it's on a finger that's spring down, so it's it can really get into the sample and intake it real nice to get it up onto this polycarbonate piece on just the new Swift slides to reach the submersible zone. And the whole intake system sits on this wrist driven by some axons, so that we have a lot of versatility in getting into the zone at depending on how far in we are. This isn't the final design. Most notably, we want to add a color sensor to it. So if we accidentally intake a block of the wrong color, we can automatically outtake it out and not get a penalty for that. And we can also pick what color blocks we want to intake. So if we want to intake, say we're on the blue alliance, and we want to intake a blue block, we'll press the button corresponding to that, and it will only intake blocks which are blue and spit out all the other colors. So that's kind of where we're working towards next with those.
What when you were looking at on your intake for it, did you have any types of intake prototypes that maybe failed or didn't work, or ones that maybe you give for advice to other teams that the reason why you went with this one was so successful and not with other ones?
The first intake we went for was 2 counter-rotating wheels to get on the other side of the block.
Sure. Yeah.
And that intake got very far in CAD, and almost was built physically, until we pivoted to the over the sample intake, because the feasibility of getting the spacing right for the 2 side rollers, it wasn't really working especially because we wanted to have it spring so that we could have a wider intaking angle, but having rollers on the side that could like smooth through polycarb on a bearing or something, that wasn't really going to work. So the over the sample intake will work a lot better. And we have printed out this the 3D printed parts of this intake, and we're looking to put it together in the coming days.
Very cool. And I remember talking earlier that you guys actually have some physical prototypes that you want to show off as well too. Is that correct?
Yeah. So here you can see this Lego model that we actually developed. Works through a cam that drives arms put together by the tension from a rubber band, and these grabbers here actually will be able to grab onto the game piece and hold it on pretty nicely. And we think that this cam design is elegant to work well with a servo. So I CAD'd this, and we have the real one built now without the servo, but we'll get that on shortly. And we have a spring up top here, providing force to this elongated cam and two arm layout, almost identical to the form factor you see in the Lego model. And after these have grabbed on to the game piece, this lip attached to the lower face will be able to push down on the game piece with the required 10 newtons of force that it takes to put the game piece onto the bar. Some next steps that we will take, though, are we want to make these a little more grippier and closer to it, because although they were designed to be loose enough to allow for some compliance here, are a little bit too loose as it stands right now. And we also want another lip up here because there are some problems with the actual scoring, and it just falls off. But we are pretty close with this design, and I'm super excited because it came along very quickly and very cleanly.
Something we talked a lot about is, different parts of your robot. Well, we haven't mentioned a lot about your climber. I'd love to hear more about some of that strategy, what your team's looking at doing, and then as well, too, anything that you can showcase for that as well would be great.
So yeah, now we're going to bring Etienne on because he's been working on the climber.
So for the climber, we also made a Lego prototype. Because it's a two-stage climb, it's a little different than usual. These black hooks it's a Swift slides that will go, and then these two white hooks are spring-loaded, so just turn a servo and they just pop out. So we climb onto the level 1 climb with the black hooks, and then we let the white hooks go, and then they just pop out. Then we just raise our black hooks back up, and then we attach ourselves to the level 2, and that's how it seems simple, but there's the weight has to be distributed properly for it to go correctly, but it should work.
When you were looking
and
at
Oscar's grabber mechanism also sits on the vertical Swift slides to pick up the specimens off the wall and score them in the chamber.
Can you talk about some of the goals behind climbing? Like, how quickly did you want to do it? Why did you want to go for a top tier climb? Things like that. So when you were doing your brainstorming, your game strategy behind it, talk to me about some of the things that went into determining why you went this route.
Originally we thought that you could climb directly straight to the top bar, which we found out at kickoff pretty shortly thereafter that you do have to do you have to grab onto that first bar, then the second bar to get the 4-point climb. And we really wanted we prioritized the 30-point climb so much because we think, especially early on in the season, being able to climb, get that 30-point climb very quickly during endgame is going to lead to the maximum amount of points a robot like us is going to be able to get pretty early on in the season. So just strategy-wise, we thought it was the best course forward.
Did you take any inspiration from any teams in regards to designing your climber?
So far, our climber has been mostly our own thought process. We've been inspired by previous climbers we've had from our FTC team and also our FRC team. But we think this climber is actually pretty unique. We think.
Very, very cool. I can't wait to see that in action. I'm sure you're looking forward to that as well too. Getting to that top tier climb, I agree, it's going to be a super important thing. And I think you're probably going to be one of the first teams to do it, and we can't wait to see what that looks like as well too. As we start to wrap up here, one of the things your team is also experimenting with is the new FTC Limelight as well too. I'd love to hear more about what you've been doing for that.
So the reason that we're switching over to the Limelight, the new Limelight 3A, is because we want to do more with vision, especially object detection and April tag localization. And we did experiment with it a little bit last season, but the reason that we want to use the Limelight specifically is because it takes a lot of that processing load off of the main control hub processor and onto an offboard processor. So we've got Nate and Etienne on the field right now. We've got one of our Limelights that we ordered is actually on a robot that we made over the summer. So we've mounted it to that just for testing purposes, and they're getting it set up right now. So we want to show some demonstration of how the April tag localization works, because what's really cool about the Limelight is it'll detect the tags, but also do all of the calculations on board to give you just a pose of where the robot is on. Connect it to see that visualization, a 3D visualization of where the robot is, of course, the camera feed and the overlay for the April tag detection. So it's very useful as a diagnostic tool, but also we're going to off here. So have you guys set it up?
Yeah, we've got a scene 2 April tags right now, and we're trying, the software is trying.
Yes, 2 April tags. They've got it pointed sort of in a corner so it can see one on each side of the frame, and it's way better when you're seeing 2 April tags, because it can actually triangulate off of both of them instead of just relying on the sort of yaw and roll of one of them. So I'd assume you guys are showing the preview right now?
Yes.
Yeah. So you can see that the robot, basically the Limelight can see where the robot is with pretty good accuracy on the field there. And then I think they're turning it now. So can you guys still see 2 April tags? Mm-hmm. Yeah. So now they're looking at, I'm assuming, a different pair of 2 April tags, and it's capturing that rotational motion. So do you guys want to try and drag it to a different part of the field, maybe? So we should be able to see that on the screen. It is now in a different part of the 3D preview. Can you guys see that?
Yep.
Yeah. So it's the yellow one, right?
Yeah.
Yeah. So there's a yellow robot sort of 3D model that's on the field, and based on where that is, that's where it's calculating the pose to be. So we thought pretty interesting, and we're definitely going to see if we can find some uses for that during auto, and also for some automated subroutines during teleop. We think that'll also be a good thing to look into.
The wrap up on this too is something I want to ask you is, for teams that have not done much with vision before, is something like the Limelight 3A does that have a pretty low barrier of entry? Is that something teams could probably get into pretty easily, in your opinion?
The Limelight 3A definitely is a lot easier in terms of sort of getting to know how stuff like April tags works, because in order to sort of preview and visualize this stuff, you don't actually need to write any code at all. You just need to plug in the Limelight and download some software, and you can see what the Limelight's doing and how it does it, and you can get a really good sense of what you're going to see when you actually start to code. And I think that even on the coding side, as I mentioned before, because it can do all the calculations by itself, it's a lot easier on the coding end, because you can just take those numbers that it produces and put them into your code. So I think it's a great learning tool for teams just starting out, as well as for more advanced teams that want to use it in more complicated ways.
So 12736 Electric Mayhem Green, got to ask you, we're going to have you back on here in just a few weeks here. Where do you want to be then? And I guess, what's your competition season look like? Are you going to be competing in a few weeks already? Do you still have some time? Where do you want to be in about 3-4 weeks when we have you back on?
We want to be in a position, hopefully in 3 or 4 weeks, we have more of a robot to show off. We want the current CAD deadline to have the entire robot CADed is the 1st of November. And we are competing pretty soon. Our first competition is in Penfield, New York in December. And then we compete again in January coming up.
Well, we can't wait to have you back on. Best of luck as you continue your build season. Thanks for showing us a lot of great things that teams can take inspiration from. So we look forward to having you back on next time, guys. Thanks a lot.
Thank you.
Thank you.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineered their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Studica Robotics is everything your team needs to build, learn, and compete. Check out their FTC Starter Kit, Intake Hub Kit, and odometry wheel options at studica.com/robots. Teams in the USA can get up to 25% off and apply for grants at studica.com/robots.